Okay, so picking up where we left off yesterday, we were talking about 4.2, our graphing rational functions. We talked about how to find the horizontal and vertical asymptotes on the front side. And then the back side, we looked at one graphing example, right? And I want to continue looking at those, look at a few pieces that happened along the way. In your class, I feel like we had enough time to kind of actually put the graph on the board, right? And we talked about a little bit that, my graphs are going to be in two diagonal quadrants, basically. So either, if we've got one here in the upper right, the other one's going to be down the lower left. Or vice versa. It could be upper left and lower right. So they're always going to have that diagonal piece, or at least most of the time. With what we're doing right now, they will. So by finding the x and y intercepts and other points, that will help us be able to place which two quadrants we're in. So let's go ahead and work our way through B. Before we graph this, remember I wanted you to find asymptotes and intercepts. And those are questions asked in homework, right? One of the big reasons I am prepping you for this, so you know what to do. Okay, remind me, vertical asymptotes. How do we find them? Okay, denominator equal to 0 is what we talked about yesterday. And my denominator in this case is x plus 8 equal to 0. If I solve that, I end up with x equals negative 8. And that is my vertical asymptote. Okay? Now, if we want to go ahead and graph that, you can graph it now, you can graph it later. Vertical asymptote is x equals negative 8. So go on the x-axis till you find negative 8. And then you are drawing a vertical dotted line there. So your vertical asymptote. Okay? That's your vertical asymptote. What about horizontal asymptotes? What was our rule for horizontal asymptotes?
The powers, the leading power from the top and bottom.
Yeah, we had to compare largest power on top, largest power on bottom. In this case, largest power on top is the 4x term. Largest power on bottom in this case is x. What do you notice about those powers? They're both x to the first. And so what is the rule when I have matching powers? We had a lot of these yesterday, right? When you have matching powers, you're looking at taking the ratio of the coefficients. So my coefficients here being the 4 and the invisible 1. So 4 over 1, or in other words, y equals 4. Okay, so horizontal asymptote, on your y-axis, go to 4. And you can make your horizontal asymptote there. Now, on the front, we pretty much just did asymptotes. But then on the back, I know some of your homework questions will ask about intercepts. So we talked about intercepts. How do we find an x-intercept? Numerator equal to 0. Because remember, x-intercept happens whenever y equals 0. And so for y equal to 0, that's when does this fraction equal 0. And so easiest thing to do is to set the numerator equal to 0. So in this case, 4x minus 3 equals 0. Add 3. 4x equals 3, divide by 4, and x is 3/4. That is your x-intercept. And I think when they ask you for intercepts in the homework, they just want you to type the number, 3/4. But if it helps you, you can also think of the fact that this is the ordered pair, 3/4, comma 0. So x-intercept of 3/4 means my graph will cross through the x-axis at 3/4, which is Right there in that little area. I know, lots of fractions, and it's not a very big graph, but we're making it work. Okay, so x-intercept happened when y is 0. When does the y-intercept happen?
Let x equal 0.
Yeah, y-intercept happens when x is 0. So easiest thing to do is to take your equation and make x 0. So in this case, 4 times 0 minus 3 over 0 plus 8. Well, 4 times 0 is 0, minus 3, negative 3, 0 plus 8 is 8. So I end up with a y-intercept of y equals negative 3/8. And that's just putting 0 in for x and doing the math out. Y-intercept of negative 3/8, so on the y-axis, where's negative 3/8? Right there below the origin, right? Again, I know, not the easiest numbers to deal with, but now, in all honesty, you could argue that you have enough information to sketch this graph. And that's all we're doing. We're just sketching the graph. We're not getting too fancy here. Because we know one piece of the graph is obviously here in the bottom right section, yes? If this is in the bottom right section, where is the other section most likely? In this upper left here. Now, my recommendation yesterday, pick a couple extra points to assure yourself. And so, and if you're not doing intercepts, you're going to have to pick the other points. But when we pick a couple other points, I want to know which side, whether I need to be up or down on each side of the vertical asymptote. And so my recommendation yesterday, right here, was to pick points on both sides of the vertical asymptote. So with that in mind, where's my vertical asymptote here? Negative 8. So what are numbers on either side of negative 8? Negative 7 and negative 9. It's not that they necessarily have to be the numbers right there on either side, but those are the easiest two to pick. So plug these in and see what kind of values we get. So if I plug in negative 7, 4 times negative 7 minus 3 over negative 7 plus 8. So that's negative 28 minus 3 is negative 31 over 1, which is going to be negative 31. We'll talk about that on the graph here in a moment. And then plug in negative 9. So 4 times negative 9 minus 3 over negative 9 plus 8. Negative 36 minus 3 is negative 39 over negative 1, which is going to be positive 39. Now, those aren't exactly numbers I can graph, but they still help me to know where my graph is. So when I look at negative 7, negative 31. So negative 7 is right here. Negative 31 means it's going to be where? Way down there. Does that fit with this graph here? Yeah, that fits because we'll be able to draw this curve in. Negative 939. Does that make sense? So negative 9 is the other side of the asymptote. Positive 39 means it's going to go where? Way up there. Does that put me in the correct corner of my graph? And it does. Okay, it does, because so if I draw, I don't like how I'm drawing that. Let me try again. If I have this piece that looks something like that, it's a sketch. I'm not looking, doesn't have to be perfect here. Then I'm looking for my diagonal pieces. So if you go diagonally through these asymptotes, then that means there's going to be a piece up in that corner. Now, I can't draw that one very accurately. I mean, it would be kind of a reflection type thing. This isn't very close to the center, so technically that wouldn't be very close to the center. I just have a hard, don't have very much room up there to draw. Okay. Questions there? Okay, well, get what you need. And then let's look at C when you guys are ready. C has a slight change, but for the most part, it's very similar. Okay, C. Vertical asymptote, how are you finding it? Setting your denominator equal to 0. So x plus 3 equals 0. Subtract 3 over. I have a vertical asymptote at x equals negative 3. So on my x-axis, I can count over negative 3 and draw a vertical line. What about our horizontal asymptote? Horizontal asymptote, you're supposed to be examining powers, right? What's my biggest power on top? Only thing I have on top is negative 1, huh? What's my biggest power on bottom? X to the first. So where is the bigger power? My bigger power is on bottom because I have an X there. And I don't have a power of X on bottom or on top. So here, this is a situation. The bigger power or larger power is on bottom. What's the rule then? It's on the front side of your notes from yesterday, right? Yeah, when the bigger power is on bottom, my horizontal asymptote is y equals 0. Okay, so it's not always using those two first coefficients. That's only when the powers match. And powers didn't match, so we had to go to a different rule here. Now, where is a horizontal asymptote y equals 0? On the y-axis, where is 0? It's right here. So the horizontal asymptote y equals 0 is the same thing as the x-axis. Okay. Let's talk intercepts. What about an x-intercept? Okay. We want y to be 0, so we're going to set the numerator equal to 0. What is my numerator? Negative 1. Negative 1 equals 0. Does negative 1 equal 0? No. Do I have a variable in my numerator? No. So this fraction can never equal 0. Negative 1 does not equal 0, so what this means is that there are no x-intercepts. My graph will never cross the x-axis. Now, if you think about it, it makes sense. My graph will never cross the x-axis. What is the x-axis acting as? It's an asymptote, right? And especially horizontal asymptotes, as we go out to the end, you never cross, you never touch, you're getting closer and closer. Could possibly touch in the middle, but that's not how this one's designed, okay? So, no x-intercepts. That happens. What about a y-intercept? We do any better on that front? Y-intercept, we're going to let x equal 0. What do we get when we put 0 in for x? Negative 1/3. Okay, that's my y-intercept. Y-intercept of negative 1/3 on the y-axis, you are going 1/3 below 0. If we wanted to, we could say we have enough information to draw this graph right now. Because here's the deal. One of my 2 pieces of this graph is going to be bottom right. Whoops. Just put a whole bunch of little marks. And if we have a piece bottom right, where's the other piece going to be? In that diagonal top left. Now, how do I confirm that? And this is where my suggestion of a couple other points. And when I pick those other points, my recommendation is near the vertical asymptote. Okay, that's my recommendation. So what are good x values to use? -2, -4. So if we put in -2, -1 over -2 plus 3, -1 over 1, so -1. If we put in -4, -1 over -4 plus 3, -1 over -1, which is 1. Do those points put me in diagonal places? -2, -1. So left 2 from the origin, down 1. Puts me down that same corner I have the red dot, my intercept. -4, 1. Left 4, up 1. Puts me in that diagonal piece there. Okay? This is a situation where my graph is going to be very close. Okay? So when I'm drawing this, what I'm doing is I am very close to my asymptotes. Officially, when I'm going through those points there near the center, they're not sharp corners, they're curves, so try and make them look like that. I know it's a little harder to do when you are that close to your x and y intercepts, or excuse me, horizontal and vertical asymptotes, but it's doable. Okay. Getting the feel for them? One more? What you got for me? Got a vertical asymptote? What's my vertical asymptote? X equals 1. Because when you set that denominator equal to 0, x equals 1. So on the x-axis, I'm going to go to 1. I'm going to draw my vertical asymptote. Horizontal asymptote. What are those biggest powers? 3x to the first and x to the first. What's that make my horizontal asymptote? Y equals what? 3. Officially, it would be 3 over 1 when you look at the coefficients, and that's just 3. And again, that's because the powers match. Okay, intercepts. X-intercepts happen when y is 0. So my fraction equals 0 when my numerator is 0. So 3x plus 2 equals 0. Subtract 2. 3x equals negative 2. Divide by 3, and x is negative 2/3. So x-intercept of negative 2/3 is going to be over there left of the origin. I did not draw in my horizontal asymptote, did I? You guys may have. I did not. Let me go back and draw that in. Horizontal asymptote is y equals 3, so on my y-axis, going up 3. There we go. Now I need my y-intercept. Y-intercept happens when x equals 0. So 3 times 0 plus 2 over 0 minus 1. What do we have? 2 over negative 1. So a y-intercept of negative 2. Y-intercept of negative 2. Left to right 0. Down 2. Okay. If you're doing this on Savas, you would probably have enough information at this point, because Savas is going to be multiple choice. We know where one piece is for sure. Then we know where the other piece is going to be, because it's going to be diagonal of it. Now, to double check, we can pick some other points. What am I going to suggest when you pick those other points? What?
One on each side.
Yeah, one on each side of the vertical asymptote. So my vertical asymptote is 1. The whole numbers on either side there are 0 and 2. Now, don't we technically already have 0 here? We do, because that would be this right here of 0, negative 2. So we already actually have the 0. 2, though, will allow us to check the piece up here. So if I put in 2, 3 times 2 plus 2 divided by 2 minus 1. 8 divided by 1, which is 8. Does 2, 8 land in the place you think it should? Right 2, up 8. Puts me in the upper right place, doesn't it? Now, if you really want enough points to make this look right, you can plug in more points. However, I'm just going for the basic shape here. And we have enough to know where my two pieces are. Okay? Whoops. Let me try and, there we go. And I'll be honest, I have not thought as to how I'm going to handle this on the test. Okay? I don't know. We'll see, you know, once we get this whole chapter together, how I'm feeling, what exactly I want to do. But I'm looking for the basics. I'm not looking for fancy graphs here. Okay? I'm not looking, you know, they're sketches. That's what I'm looking for here. Okay, you have a little bit of time. Use it. Lesson, what are we in, 4.2? In Savas is available. So get to working on it.